We're going to finish section 7.2, and we're going to pick up where we left off last time, which is with rounding. And we've gotten to this slide, I think. Does that look right to you guys? Okay. All right, so we've been working with decimals. We've been talking about adding and subtracting them, and then the last thing we were doing was multiplying and dividing, and now we're going to take a look at rounding them. And the first thing we're going to do is we're going to talk about what we mean when we say rounding to the nearest, and then you see a blank there. So it's kind of like a fill in the blank plot problem. You can put whatever decimals, location, place you want, 100 or hundredths or thousandths or 10 millionths or whatever in that space, and this will work. So what you do is you find the location you're supposed to round to, okay? And then you look at the decimal the next place after that. So for instance, if this said hundredths, so we'll fill in as an example, hundredths. You take whatever decimal value you have, and that's the hundredths place, right? And what you actually do is you look at the value afterwards. If that value afterwards is a 0 through a 4, then the number in the hundredths place stays the same. In essence, we round the number as a whole down to that value by dropping off the end of it. If the number is 5 through 9, then we round the value that's sort of I'm pointing to, if you will, up to the next value place. So we're sort of increasing it by, again, we drop off the end of the number, but we take the number that was there and we use the number higher. There's another type of, it's not called rounding, it's called estimation, but rounding is also a way of estimating. So this is another type of estimation. It's called front-end estimation. And what front-end estimation does is it just drops off everything after the value you're looking at. So in essence, it rounds everything down. Okay, so front-end estimation, whatever place value it's talking about, everything else turns to nothing. Okay, so it's kind of like you've only got 0 through 4 as the next value. You're always rounding down. So we're going to take an example, and we're going to use both of these types of methods for rounding or for estimating, rounding and front-end estimation. Now, I want you to take a look, because I wrote this direction exactly like some of your directions are written. These directions say use A, rounding, B, front-end estimation to estimate the following. What do you see as a problem with the way that this is worded?
You can only use one.
You
can only do one.
Well, we're going to do both of them in 2 separate steps, but there's something else. Yeah, it doesn't tell us what place to round to, does it? Not especially helpful. Now, in reality, that's the way life works, though. If you're trying to do some kind of rounding, nobody in the grocery store says, ignore the decimal place, right? Just pretend like these are whole dollars. So there's some sort of practical sense of that being realistic. Problem is there's no context, so you don't really know what these numbers mean. So does it make sense to talk about the decimal places? Does it not make sense, and so forth? If you're not given any indication as to how you're supposed to do it, you get to choose. All right? So here's what we're going to do. I'm going to use just the tens place as my rounding place. So we're going to round this one to the nearest tens, just because that's what I picked. That's the only reason. Okay? That's the only reason. You could likewise have picked the ones place if you want, or something else. All right, so the first way we're going to do this is we're going to do this with a rounding. So taking a look at the number 89.47, looks a lot like $89.47. If I'm rounding to the tens place, what does that become? 90 is correct. So what did we do? Well, you looked at the number after the tens place, which would be the 9. It's 5 through 9, so we round the number 8, the beginning, up to the number 9. So we've got 90. How about the $32.16? 30, right. So again, we look at the place value after, which would be the 2 here. This 2 is in that 0 to 4 range, so we take that and we wipe it out to the number 0 and everything afterwards to the number 0, which takes the number 32 and rounds it down to 30. All right, and then this problem says we're supposed to subtract, so 90 minus 30 is 60. So this is rounding. You've done this quite a bit. Front-end estimation, although also is a very helpful estimation technique. In general, it's not as accurate as rounding, but it's certainly quicker because you don't have to worry about do I round up or down. What we do when we do front-end estimation is we look at the number 89.47 and we write 80. Because whatever the place is that you're rounding to, you just use the number that's in that place and everything else goes away. The number that's in the tens place is an 8, so I write 80. And then we look at the number 32 and we say, okay, well, I do the same thing. The number that's in the tens place is the number 3, and then I zero everything else out, so I get the number 30. So you can see sometimes I get the same number, right? 30 is the same on both of them, and sometimes I don't. If I do this subtraction, I get the number 50. And if you will, there's a part C here. It's not written as C, but it says, then perform the computation to see how close your estimates are. So we're going to do part C, if you will, which is to actually subtract. All right, so we're going to actually subtract, which means at least one of the ways that we've done it most frequently is we start on the right-hand side and we're going to go down. So 7 minus 6 is, 4 minus 1 is, 9 minus 2 is, 8 minus 3 is 5. And to be honest, oh, I put a dollar sign because I'm thinking money. We actually weren't told it was. This is 57.31. It actually ends up being closer to the rounded version. It wouldn't have to be. It could be actually closer to the front end estimate. It really depends on what numbers you are working with. And it also depends on how many place values you kept. For instance, if I used this to the ones place, I might find out that one of these answers is more accurate as an estimation than the other, but once I did it to the tens place, I got a different, better estimate. Does that make sense? So these are both just different ways of doing estimation. All right, now this one actually, we're going to practice which place value we're estimating to. This one is rounding, so rounding means the 0 to 4 and the 5 to 9. Okay, that's what we're doing, the traditional rounding that you're most familiar with. This one says we're going to round to the nearest 100 as the first place. So if I've got this number 2036 decimal point and then 651, what number is in the hundreds place? Right here, yep. So I look at that place, and I look at the place after. What does that 0 tell me? I'm going to round down. So what was this number going to round to? 200.
Is that how you want us to show it?
You don't even have to really show work for this. Just in case we're sort of clarifying that 100 versus 100th, I want to make sure everybody's seeing the difference. I know you guys have seen this and done this before. This is definitely nothing new. I just want to make sure that I'm being very clear, especially with the noise outside, which is so exciting. So, all right, the next one. We'll do the same thing again. Hundredth. What value is in the hundredths place? That's our 5, which means we look at the number afterwards, 1. So what does that 1 tell me I'm going to do? Yeah, it really means I'm going to leave the 5 as it is, right? Some people like to think that that doesn't round it down. It really does. It rounds the whole value I started with to something smaller because it turns everything else into zeros. Okay, so it doesn't like turn the 5 into a 4. Sometimes I do have people think that that's what I mean by saying it makes it smaller. We want to leave the 5 the same, which actually means I've got a number smaller than what I did because in essence it turns this 1 into a 0. That's what it does. And then what do we mean by unit? The ones place. So sometimes you'll hear the word unit used instead of the word ones place used. And in the ones place, or the units place here, I have the number 3. So the number 3, and then the number right afterwards is the 6. So what is this going to be when I round it? Right, the number 3 gets rounded up to the number 4, so this is 204. This is what you would do if you actually owed money in a store, right? If you gave them $203, that's not going to work. They're still going to say, where's my 65 cents? They wouldn't have the 1 on the end, but where's my 65 cents? So, all right, one more question, and this is an interesting one that I want you to see. A student tries to calculate 999 thousandths to the 10,000 power on a calculator. He finds the answer to be 4.5173346 times 10 to the negative 5th. Now, let me just remind you what this actually means. This means we have a decimal point. It means we have 4 zeros. And then I have the 4.5173346. Okay, that's the number that he's getting, but it's putting it in scientific notation, which your calculator will sometimes do. So it's a really small number, right? Practically 0. If we were dealing with money, it would be 0. Agreed? All right, the student wonders how it could be that when he started with the number 0.999, which was so close to the number 1, and he raised it to a power, how it turned into a number so close to the number 0. right? Because normally, right, if you took the number actually 1 and you raised it to a power, it would still stay 1. It wouldn't change. So the question is, why is that doing that? Why is it doing that? Any thoughts?
Can you think of it in terms of fractions?
I think that's a good way to think of it. So what did you have in mind, Allie?
Like if you do the 999 over the 1,000,
Mhm.
then if you like do fractions and you do exponents, it's going to get smaller because you're multiplying it by itself.
Yeah, that's really the issue. And it's the issue whether you use it in fraction terms or whether you use it in decimal terms. And we encountered it already in fraction terms. In fact, it showed up on your test, and some of you have been in and you've talked to me a little bit about what that happened on your test, right, Amanda? Yeah, we talked about it this morning. When you have a fraction, or in this case, a decimal that's smaller than 1, and you multiply it towards something, whether it's itself or something else, what happens? It gets smaller. So this is definitely makes sense that it should be getting smaller. Now, it's possible the student recognizes, hey, it should be getting smaller, but they're still maybe recognizing or asking, but why in the world did it do it so drastically? I mean, it went all the way from 1 to 0 virtually. So I want to show you an example of how to think about what's happening. And this is, I wouldn't expect that you'd write this down. I just want you to see that this is what happens when you multiply by a power, not by a power, excuse me, multiply by a number that is less than 1. So we're actually going to consider the number 999 thousandths. And you're going to grab your calculator out because you're going to need it. Okay, so if you don't have it with you just right yet, grab it. And I just want you to square it. So put 0.999 squared. Okay? And I'd like to know, what do you get? Excellent. Everybody get that? Okay, keep that on the screen of your calculator. No matter what calculator you're working with, you're going to be able to do this next, okay? Or at least as long as you have exponents, you will. All right, what we're going to do next is we're going to square that result. Now, in essence, I'm going to show you what we're doing, and I'm going to talk a little bit about what's actually happening in terms of your exponents. So we're taking that 0.998001, and we're going to square it. So when you square something twice, remember exponents, what that really means, this is equivalent to writing down this number to the 4th power because you've squared it twice. So that's what we're doing. We're just increasing the power is all we're doing. So what happens when you square this again?
996,
Okay, I'm going to go with 6 decimal points as we're working, so let's just go 6 here on the end. Is that okay? You don't need to abbreviate in your calculator. Just let your calculator have all its fun decimals it has, but just for writing it down, I'm only going to write 6. We're going to square it again. So in your calculator, if on the screen where you are, if you just hit squared, it should automatically square the previous answer. So I'm taking this previous answer, 996,006, that's my approximation for it, and I'm squaring it. So if I square something 3 times, that's actually a power of 8. Are you guys with me? Because you multiply the exponents, it's a property of exponents we learned about in the last chapter. Remember that? The exponents get multiplied, so 2 times 2 times 2 is 8. So this is actually, in effect, a power of 8 that we're finding. What did you get?
0.99203. I mean, it goes on to that.
Yes. How about 28? If I'm going to use 6 decimals, I'll write 28. That's okay. Okay, so this is a power of 8, right? This is all we've done. This is a power of 8. If I do it again, it becomes a power of 16. Let's do it again. Just hit squared, and it's going to tell you another answer. What do you get? Oh, goodness, we're out of the 99s, aren't we? I have 119. 119.
Yeah.
Is that okay? If you write down 1, 2, it's okay. So this is the power of 16. Let's do it again. If I do a power of 16 squared, what do I get? It's be power of 32. 984,119 squares. This is basically a power of 32 now. It's easy. You just hit squared in your calculator, right? What'd you guys get?
0.96849.
Okay, do it again. I promise we're not going to do this all day. We will stop very soon. 8491 squared. What'd you get?
93797.
It's coming down, but I mean, seriously, we're still talking 90 cents here, more than 90 cents if we're working with money, right? This is not coming down very quickly. Let's take it again. Oh, I'm sorry. I wrote the same one we just did a minute ago. 937975 is where we were. Did we get into the 80s? Oh, that's super exciting, isn't it? All right, 8, 9 rather. Did I have 9? 7? What's next? 8, 7. A couple more times, okay? Yes. 774043. Square that. What do you have? 599142. Exactly one more time and we'll stop, okay? 599142. What happens when we square this one? Do you have 3, 5? I know it sort of felt like it was like we did a lot of steps in that. Count how many steps you really did. Count them. How many times did we do this? 10 times. It only took us 10 times of squaring and we got a number smaller than 1/2. So it really doesn't take that long, honestly, before we get a number that's getting to be quite close to 0. I mean, this is super close to 0 compared to where we were before at the number 1. So the issue has to be with the number that, or the issue has to do with the fact that when we multiply by a value smaller than 1, the product, that means the result of the multiplication, the product becomes smaller. And in essence, we're going to try and do that on this problem. In essence, this kid is doing this how many times? 10,000 times. So should it be getting smaller? Yeah, it should be getting very small. He's done it 10,000 times. Okay? We do it 10,000 times. So yeah, it's definitely going to be getting close to the number 0. Why can't it go below 0? Yeah, these are all positive numbers, right? You don't get into negative numbers unless you start multiplying by a negative number, and we're not doing that. We're multiplying by only positive numbers. So we'll keep getting closer and closer and closer to the result of 0.